Welcome back, guys, to another Medporium video. Today we are going to go over Zaitsev's rule, and it states that the major elimination product is formed by deprotonating the carbon attached to the fewest hydrogen atoms. And basically what this means is that the double bond, upon whenever an elimination reaction occurs, it is going to choose the carbon that has the least amount of hydrogen atoms and making it the more stable carbon. So the double bond is going to choose the more substituted carbon. It's kind of another way to think about it. So now let's try and decipher that definition with an example here. We have an alkyl bromide, and I'm going to react it with a relatively strong base. And there's some other stuff, maybe heat or another solvent. But for now, just to get the general idea, we are reacting it with sodium methoxide to try and eliminate that bromine. And remember, whenever that elimination occurs, there's that double bond that's going to form. And so how I kind of like to tackle this is I like to list out my hydrogens that are missing. So I have one hydrogen here. I have 3 because it's a primary carbon. And then over here I have 2 because it's a secondary carbon. So now I have 1, 2, 3. And as we learned in our definition, that double bond is going to prefer the carbon that has the least hydrogen atoms. And so our major product is going to be this. It's going to want to choose that carbon right there. And it's not going to go to 3 or 2 because those are least stable and least favorable. And it's very similar to carbon cation stability, where the tertiary carbocation is the most stable. And so that's what we have right here. We have a tertiary carbon. So this is our major product. And we're also going to get a minor product. And an example of that could be this right here. And this is our minor. And this is sometimes referred to as the Hoffman product. And the Hoffman product is sometimes preferred, especially whenever there's like a strong bulky base. So just keep that in mind. Let's do another example here. And I'm just going to attach a chloro and an ethyl. And a question that you might be asked on an exam is to locate which one of these carbons is the alpha carbon. So go ahead and pause the video and see if you can figure out which one of these carbons is the alpha. And simply put, the alpha carbon is the carbon directly attached to the leaving group, or in this case it's our halogen here. And the rest of these carbons, I'm going to put in blue. The rest of these carbons are simply referred to as beta carbons. Now, another question that you may be asked is to locate which carbon is the Zaitsev preferred. So where is that carbon going to bond, or where's that double bond going to attach? Which carbon is it going to want to prefer? And in this case, what I like to do, as I mentioned earlier, is to list out my hydrogens. I have 1 there, I have 3 over here. This is full, and I have 2. And as always, the more stable carbon is going to be the tertiary carbon, the one with the least hydrogens and the most substituted. And like I said, it's very similar to carbocation stability as well. And so the double bond is going to want to come here, and once that chlorine leaves, it's going to want to attach here. So we'll kind of get a structure like this. Something like that. But anyway, for the question itself, which carbon is the Zaitsev preferred? our answer is going to be this carbon here, and we'll just call it carbon B. So that is our answer, and we'll call this carbon A for alpha, and that is our answer there. And another thing to keep in mind is that the E1 reaction mechanism must obey Zaitsev. And that is it. Thank you guys for watching. I hope this helps, and I'll see you on the high tide.